In this video, we are going to solve 2002 AP Calculus AB FRQ question number 6. So it gives us a chart with the position function and the derivative. It says let f be a function that is differentiable for all real numbers. The table above gives us the values of f and its derivative f prime for selected points x in the interval from negative 1.5 is less than or equal to x, which is less than or equal to 1.5. The second derivative of f has the property that f double prime of x is greater than 0 on the interval. Okay, that part's important. They usually throw it in later on into a question where you're going to have to relate that. So part A says evaluate from 0 to 1.5, 3f prime of x plus 4 dx. Show the work that leads to your answer. Okay, so let's write that down. So now you could break up this integral. Oh, and I need the interval 0 to 1.5. You could break it up from 0 to 1.5 f prime of x dx plus 0 to 1.5, 4. So now, what's the antiderivative of f prime of x? That's f of x from 0 to 1.5 plus, what's the antiderivative of 4? It's 4x from 0 to 1.5. So now we have to look at f of 1.5. F of 1.5 is negative 1 minus f of 0 is negative 7 plus this would be 6 minus 0. So now you're going to get 3 times positive 6 plus 6. So you're going to get 18 plus 6, which is 24. Okay, part B. It says write an equation of the line tangent to the graph of f at the point where x equals 1. Use this line to approximate the value of f1 of 1.2. Is this approximation greater than or less than the actual value of 1.2? Give a reason for your answer. Okay, so now we need a point and we need a slope. It says it's at x equals 1. So if you look at 1, it's 1 comma negative 4. That's the point. And the slope is 5. So that makes that really easy. So it's y plus 4 equals 5 times x minus 1, which is going to be y equals 5x minus 5 minus 4. So now we're going to get y equals 5x minus 9, and now we're going to plug in x equals 1.2. So now we're going to get 6 minus 9, which equals negative 3. Now the question says, is this an approximation greater than or is it less than? So this approximation is less than because, you can't see that, because f double prime of x is greater than 0. It's always concave up. That's the part that was important over there. It says C. Find a positive real number R having the property that there must exist the value of C with 0 is between 0 is less than C, which is less than 0.5, and f double prime of C equals R. So we have to find the number R. Give a reason for your answer. Okay, so we're going to use this interval. So that's pretty easy. We could do f double prime of C equals f prime of 0.5 minus f prime of 0, 0.5 minus 0. So now what's f prime of 0.5? That's negative, no, that's 3. Minus, what's 0? It's 0 also. over 0.5, so we're going to get 6. So r equals 6. Okay, part D. Let g be the function given by g of x, 2x squared minus x minus 7, for x is less than 0, and 2x squared plus x minus 7 for x is greater than or equal to 0. And now it says the graph of g passes through each of the points x comma f of x given in the table above. Is it possible that f and g are the same function? Give a reason for your answer. Okay, so part D. What we could do over here is we could write f double prime. Actually, we don't need f double prime. Let's think. So we could say it's probably a limit. Let's try limit. Limit as x approaches 0 from the left, which is going to be the derivative of g of x, which is going to be, what's the derivative of this guy? 4x minus 1. And if you plug in 0, you're going to get negative 1. And now if we do g prime of x as the limit as x approaches 0 from the right, that's going to be 4x plus 1, which equals 1. So now we could say g prime is not continuous at x equals 0, but f prime is continuous at x equals 0. So f does not equal g. And I hope this video helped.